In this tutorial, I'm going to be outlining how to generate a simulated dataset for a user-defined parameter values for both m and b in this model y equals mx plus b. And the assumption here is I'm assuming that we already performed a fit to y equals mx plus b. So we have a model simulator file, but now we want to use our particular parameters for m equals 25 and b equals 2.5. So how we achieve this is we're going to, here I have the simulated dataset file, which is shown here. And all that's in this file is this Excel sheet. So the first thing I'm going to do is to go into our model simulator scripts. I'm going to go down to the simulate dataset file, and I'm going to copy that file over to our simulated dataset directory. I then am going to copy this location over into MATLAB and navigate there. Now I need to get a model simulator script to describe y equals mx plus b. So that I have already made, and is this model simulator shown here. So depending on the model you're working with, you'll need to copy over the particular model simulator file for that particular model that you're working with. So if it's a reaction scheme, you need to copy over that model simulator. If it's a closed form expression, you need to copy over that model simulator. So now if I go ahead and open up this model simulator, as you can see, this is for the y equals mx plus b example. So we have mx plus b, we have m and b of both parameters, and x is the independent variable, which is ideal for what we're trying to achieve here, which is simulating a data set where we're simulating the equation y equals mx plus b, where m is 25 and b is 2.5. So now, as written at the top, I identify which sections need to be modified to simulate your data set. So we just need to modify sections 2 and 3. So in section 2, you're going to be defining your independent variable. Wait, excuse me, this is the model simulator. So now we need to actually copy this model simulator file, I made a mistake, and put it into this simulated dataset folder. Okay. So now if we open the model simulator, once again, we have mx plus b. So this is indeed the correct model simulator. And now if we open up the data simulator, you'll see that we need to modify sections 2, 3, and 4. So now in section 2, we're defining the independent variable. So where we want the independent variable to start, where we want to end, and the number of data points. So I'll just leave this alone at, we'll start at 1, we'll end at 100, and we're gonna have 100 data points. Now, this is all that section 2. Now, section 3 is identifying if you want the data points to be logarithmically spaced or linearly spaced. Here, I'm gonna make these linear. So we will remove the percent sign. So you can do that by hitting this button or adding it shown through here. So now by removing that percent sign, it now makes this code active. So independent variable will be defined linearly. So these data points will be linearly spaced data points. And now the parameters that we're working with are m and b. And now it's important that the way we list the parameters here needs to match with the model simulator. So the model simulator has them as m and b for params 1 and 2. So it needs to match here. And now I'm going to choose values of 20 and 2.5. Oops. For both m and b. And now we update this portion to have the parameters m and b. So now we've edited sections 2, 3, and 4. 2, 3, and 4. So now to simulate the data set, you simply press run. And as you can see on the right-hand side, the simulated data set is now in the workspace, where your first column is your independent variable and your second column is the simulated data set. So now you can copy that and paste it here. So now we've generated a sample or an example data set where the slope is 25 and the y-intercept is 2.5. and we're having our time points start from, or our independent variable starts from 1 and ends at 100. So here I've shown you how to generate a simulated data set using MENOTR.